We have built what we call now a foundation model for materials and processes. We have also built a world model for all this manufacturing environment, in addition to the large skill set that we have developed with physical AI for our robots. We have processed more than 30 million square feet of surface area. That's more than 520 football field worth of surface area. And that's growing exponentially, right? We have robots deployed across aerospace, specialty vehicles, marine, national security related operations, and consumer products, many different industries. People don't believe that. But then when they come see it in action,
looks like magic.
Their mind blows away and they start seeing all the possibilities, and then they start pushing us, hey, why not this? Why not that? Why don't you do this? Some of our customers, they love us. The end users, the operators, they love us because we make their life so easy after implementing the robot. Some of them told us that I can now go back home, play with my kids or my grandkids. My body doesn't hurt anymore, right? So those are some of the profound impacts that we're after. Our goal is to build manufacturing resilience. When it comes to super sophisticated sanding, grinding, painting, coating, blasting, like these complex tool manipulation problems, you have to deliver superhuman performance. Humanoids are not the right form factor.
Welcome to DeepTech Unleashed, a global conversation about building the next generation of iconic technology companies. I'm your host, Debjit Mukerji, partner at NGP Capital in Palo Alto, California. If you're passionate about deep tech startups or about the power of innovation in unlocking brand new market opportunities, this podcast is for you. In each episode, we invite a leading deep tech founder to come share their insights, their challenges, and their special moments. Today, we're delighted to welcome Dr. Ariyan Kabir, CEO and co-founder of GrayMatter Robotics, based in Los Angeles, California. GrayMatter is building a generalized robotic intelligence for manufacturing. This is what I call true AI-backed robotics. It's adaptable, it's flexible and generalizable, and it produces superior speed, consistency, and quality in its output. Ariyan and I first connected about 4 years ago. He was still early in the business, raising his Series A, but there are a couple of things I saw that I really liked. We continued to stay in touch. I developed conviction about the business, and NGP Capital invested in the Series B in 2024. Ariyan, it's a great pleasure to have you here. Always nice to see you. Welcome to NGP Studios here in Northern California, the better part of the state, and look forward to the conversation.
No, thank you, Debjit. I think Southern California is the better part of the state.
I'm glad we're getting into debate early in the conversation. So in this episode, we're going to cover a lot of ground. We're first going to talk about your specific personal background, your research spike and expertise, how it led you to GrayMatter, a little bit of the founding story. Then we'll get into the market opportunity. You're addressing a vast unaddressed opportunity today in the face of great labor shortage. So we'll talk about that. And then I would love to get into product and technology. As I mentioned, AI is the backbone of what you do, and would love to hear about how that's developed and what the vision and the roadmap for the company are. And finally, we'll wrap with go-to-market and customers, and specifically you've developed over the last couple of years a real competency around dual use. So addressing not just great commercial opportunities, but also government and defense.
Sounds great. Perfect. Let's jump in.
Fantastic. Let's get started. So first of all, tell us a little bit about your own personal background. Maybe a little bit about what excited you as you were growing up. Were you always a science and engineering geek? And then walk us into kind of your PhD and what you studied and what led to GrayMatter.
You know, as any kid growing up, you're always excited by robots, right? So that's, no question at all. However, I think like the first time I started to think about pursuing a career in robotics and AI was during undergrad, during college, when I was doing my, bachelor's in electrical engineering. During that time, so I grew up in Bangladesh, and there was a natural disaster. There was a big earthquake that led to a lot of different challenges, a lot of buildings collapsed and all that. And not just that, a lot of lives were lost, not just from the earthquake, but also during the rescue mission. And what was very evident is that there are a whole bunch of activities that people should not be doing, that should be all done by robots, right? Let it be rescue, let it be very hard industrial operations, let it be things around national security. And during college, what I found out is that there are so many different robots that were still available, able to do Herculean tasks, but there was no intelligence to make them adaptable to the real world outside of very confined workspace or very confined operations. So that pushed me into thinking, okay, how do we bridge that gap? So that led me to pursue my PhD at the intersection of robotics and artificial intelligence. And I was very fortunate to be part of USC, University of Southern California, where one of my co-founder, our chief scientist, SK, he started this center called Center for Advanced Manufacturing. And that was mine and my other co-founder, Bruel Shah's, our co-founder and CTO, two of our first exposure to manufacturing. So this is 2016. And before 2016, neither of us knew how things are made. We thought everything is made by robots and physical objects just appear in front of us, just like you see in a Tesla or Toyota factory videos, right? But then being part of that center really helped us interface with a range of manufacturers, anyone from Fortune 100 all the way to mid-sized businesses, sharing their pain points and challenges, how vast 90% of manufacturing is high mix by nature. You have part-to-part variation, material distributions are different due to the process physics leading variability. And you can't really have a hard-coded robot like the automotive industry. In automotive, electronics, or food and beverage, you have machined metal parts or stamped metal parts. You hard-code a robot repeats the same thing again and again. Outside of that, vast 90% of manufacturing, anything from musical instruments to football helmets, to your household furnitures, to large transportation, buses, trains, trucks, fire trucks, ambulances, boats, yachts, submarines, aircraft carrier, commercial aviation, defense articles, space transportation, energy, you name it, all are done by people by hand, vast 90% of manufacturing. So that exposure was unreal for us. And that led us to thinking, okay, how do we solve this problem and create autonomous robots to solve these challenges of capacity constraint and challenges of scrap, repair, and rework that comes from human mistakes.
Yeah, that's amazing. You're painting the picture of a not small market. It's obviously huge and unaddressed. And that's a fascinating kind of journey in. It seems like you learned a lot in your PhD and you were exposed to things that you didn't know about before. What was it like? Give us a little sense for what it was like going from research to being a founder, making that transition to being an entrepreneur.
Yeah. It was a journey. So I think, when we got that exposure at the Center for Advanced Manufacturing, between then until we started the company, right before COVID, not the best time, but we have been very fortunate. Great team, great sets of customers. So between that period, we were fortunate to be exposed to a range of manufacturers. And what we learned is that this is a global problem. This is not just a problem in the US with big defense manufacturers. And anything from football helmet to fire truck to fighter jets to submarines, everything needs autonomy to be able to bring robots in and bridge that gap between demand and capacity. We saw there was a growing backlog. If you're a city, you want to, get a fire truck for your city, you have to wait between 3 to 6 years.
Wow.
There's a 5 million man-hour short in our submarine industrial base today. So in early 2020, what we saw is that, anyone doing robotics and AI are focused on two things, either self-driving cars or pick, pack, and ship material handling application. No one is paying attention to this massive, more than $7 trillion global opportunity of everything that's done by hand by people in manufacturing. And that gap is growing.
Do you think that is because the problem was just too hard?
It's a combination, yes. One is the problem is very hard, very difficult to solve, right? Because you need to deal with complex physics of materials. You need to deal with complex physics of environment. There's so much minute physics of how does two different materials interact with each other. Their properties change with respect to temperature, humidity, the viscosity of materials changes, so on and so forth. Your environmental lighting condition plays a role. So the complexity and the dimensionality of the problem is very, very large. And on top of that, the other big piece is the need or the pull from the market, right? That started to grow exponentially. The demand for physical products keeps on growing exponentially, but the available labor force is reducing also exponentially. So the gap keeps on rising. So that was very clear and very evident. And we were very fortunate to get that exposure, speak to a range of different manufacturers. Actually, I still remember before starting the company, between December 2019 to January 2020, we interviewed more than 150 people from manufacturing. And it was very clear to us that it's a must-have. It's a medicine, not a vitamin. Someone has to do it. Better be us.
No, that's great. I love that. Maybe tell us a little bit about the personal dynamics. I mean, I did a PhD. I know, what it was like with my advisor. What was it like starting a company with your co-founders being your advisor and one of your colleagues in the research group?
It was actually fun. So, Brual, Iske, and I, we met each other. Three of us met in 2014. So that's when I joined Iske's lab in University of Maryland before moving to USC.
Mm-hmm.
And Brual was working on unmanned boats. In Iske's lab, there were anything from robotic BART to like unmanned boats to complex manipulation. And what really brought us together to start the business is the fact that this problem needs to be solved and the vastness of the problem and the timing of it, right? And being part of that Center for Advanced Manufacturing, that's where all these manufacturers kept on telling us that, hey, we need this. This has to be done. Without this, we can't really future-proof our business. So the evidence was very clear. We never really I never in my life thought about making a robot that can stand a table or a bus or a fighter jet, right? Or do so many sophisticated complex inspection and other application. But it was that exposure and being at the right place at the right time. To be honest, we have been very fortunate. And three of us really aligned. You need a team who has been exposed at the intersection of manufacturing, robotics, and AI.
Mm-hmm.
If you have general AI or digital AI background, it really doesn't translate well when it comes to the physical world.
Were there one or two key things in your PhD thesis that translated perfectly to maybe the early IP of the company, or to unlocking a critical problem in the early days?
I would say during PhD, getting the exposure to the problem was the biggest unlock. However, some of the work that I had done during my PhD, to be completely honest, right? I even had some patents during my PhD. But none of those technology, when we started the company and started to work with real parts in real manufacturing environments with real robots, we were not able to translate that technology in the real world.
Yeah.
We had to revamp from ground up at GMR and build, completely new IP, because latency has to be low. You have to adapt to the real world. All these material complexities, environmental complexities are there. So it had to be new. And Debjit, I'm curious, how about you? You also came from, doing your PhD. Now you're an investor in deep tech. How was that journey like for you?
Well, it's a really interesting journey, and it's a kind of a long evolution, I would say. But I think for me, it was, if I were to describe it in a few words, it would be research was fantastic in terms of going very deep. I think at that time in my life, I wanted to go as deep as I could and understand one problem maybe more than any else in the world. And that was great. So it scratched that itch. But then as I was finishing my PhD, I realized I'd love to learn about so many other things.
Mm-hmm.
And one of my professors on my reading committee was starting a company. He invited me to basically consult with the patent lawyer to help set up the foundational IP. It was in microscale heat transfer, which is a space that a lot of people don't know well, but right. I knew a little about it.
No wonder you can relate so much with what we do.
Yes, exactly. I think so. And that kind of started things. So I worked with a venture capital firm, worked with a lawyer, and then I started to do some consulting for VC firms. And I realized that it satisfied my desire to learn, to keep learning about new things. And then I finally came over full-time in 2005. So it's been 21 years in the industry. Wow. And for me, the best part of the job continues to be meeting great entrepreneurs like you and learning. The fact is, founders today are leading their categories. They are innovating in a practical way more than anyone else. And that's what I loved about my transition, is that research was great, but it felt even greater to see the practical translation of great innovation into something that impacts the world.
Awesome.
And so I love that.
Awesome.
Let's transition now a little bit into market and the problem you're solving. You already alluded to this. It's a vast, kind of untapped, in some ways, market. There's a lot of labor. If we look at manufacturing in the US today, we know that labor pressure is acute. So we're really facing a crunch. where automation probably needs to fill the gap. I'd love for you, because you see the customers every day and you're on the ground, to give the viewers a sense for how big this opportunity is, number one, from a market standpoint. But I would also like you to talk about the human element. When I did diligence on GrayMatter, I was shocked at how difficult, dangerous these jobs were for humans. These are things that people really shouldn't be doing. So would love to hear both about the market opportunity and size, as well as the human element and what you do every day to improve quality of life.
Awesome. Great. Yeah, I mean, to your point, the market is massive. So you mentioned, yes, you're right. There are 500,000, jobs open, unfilled today. In the next 9 years or so, that number is growing to be 3.8 million. So by 2033, 2034, in the US, there will be 3.8 million unfilled skilled manufacturing jobs, right? And that's going to put our economy at a risk of several $1 trillion. It's insane. It's growing very, very rapidly. And, to your point, global, this is not just a problem in the US. This is actually a global problem. Globally, if you look at all of manufacturing, everything people are doing by their hand today, just by labor wage, forget other operational expenses, just by the labor wage, global manufacturing manual operation, that's more than a $7 trillion market.
Amazing number.
Today. Out of that 7 trillion, if you only focus on just tool manipulation problem, applications where you take a tool, you make some value-added change to an object with the tool, that segment of the market is more than $4 trillion globally. These are applications like sanding, grinding, painting, coating, blasting, deburring, riveting, you name it. Different tool manipulation problem. These are, by the way, the reason that is so large is because these are high-skilled jobs. It takes someone 4 to 6 months to become really good at sanding. It takes someone more than a year to become really good at painting kind of operation. The really good painters, even in the US, really great painters, they're making anywhere from $100,000 to $250,000 a year across the different manufacturers that we work with. And then if you take that $4 trillion global opportunity and just focus on North America, that's about $1.4 trillion opportunity annually. Now, the market is massive. The need is, it's a must, right? The problem has to be solved. To your point, as the available labor force is shrinking and the demand of physical products are growing for our lives, for our, all the services that need to be there in the world, also for our national security, that gap keeps on growing. And that becomes really challenging problem to solve, because now you need to, manufacturing is upstream of everything else. It's a cascading catastrophic effect on the whole economy. So it's a must solve problem. Now, the reason why there is this growing shortage of skilled labor is, to your point, these are very tedious and ergonomically challenging jobs. People no longer want to do it. When you do this for 3 years, 5 years, 8 years, you're sanding or grinding or painting, you end up getting carpal tunnel, shoulder injury, back injury, respiratory problems, and whatnot. Some of our customers, they love us, the end users, the operators, they love us because we make their life so easy after implementing the robot. Some of them told us that I can now go back home, play with my kids or my grandkids. My body doesn't hurt anymore, right? So those are some of the profound impacts that we're after. Our goal is to build manufacturing resilience, right? Our goal is to build this resilience in our lifetime and then also improve the quality of millions of lives within our lifetime by introducing autonomy across this factory layer.
And I think we're going to spend even more time talking about the market and opportunity because it is so vast. And there's a deep human element to this, as you mentioned. Let's talk a little bit about the technology and get a little technical. The problem that you're solving is incredibly difficult, as we said at the outset. And maybe that's why there haven't been a lot of entrants in this field. Let's take sanding as one example.
Great.
First, you have to do a detailed scan, an optical scan. It's a complex 3D object. It could be very large. You're dealing with different form factors.
Yeah.
And then on the physical interaction, I think, this is something that I think a lot of people don't understand, is sometimes you have robots that just move around, or sometimes you have robots that just need to move an arm to a specific position, which is predetermined. In your case, you're actually dealing surface to surface. You have many, many variables. You have different materials in contact with each other. You have input variables like the pressure that you apply to the surface, the RPM of the end effector, the translational speed of the arm. And not everything is perfect. So there's real-time conditions, as you mentioned, environmental factors even. And so this whole system needs to adapt in real time, which is incredible. I think one of the things that I really liked about it was there is a manipulation piece. And we talk in robotics a lot about dexterity. Dexterity being kind of the next frontier. You're really pushing the envelope in terms of dexterity. So this is what I would call a very sophisticated dexterous system. Can you give us a sense? I kind of laid out the overview, but can you give us a sense for how difficult it is to build a general system and the general AI to power this system to accommodate all these different parameters?
Sure. That's a great question and a very loaded question. If you look at the people who do all this, the people who are doing all these jobs by hand in the factories today, right, in manufacturing today, they're treated as craftsmen. They're treated as artists or artisanal work that they're doing. But in reality, there's deep science behind everything that they're doing, right? They just happen to master that complex activity so good, so well, it's so intuitive and natural to them. Now we have to translate that for robots to be able to do. And that involves, to your point, very complex material science. So taking sanding as an example, as you rightfully mentioned. So why do people sand? People typically sand for a few different reasons. One, there might be some aesthetic reason. You want to get a certain surface finish that looks good for certain applications, certain parts that you make. There can be a reason you want to abrade the surface so that you can paint the surface. Paint can adhere to the surface. There could be also a reason where you are shape correcting, right? You're adjusting the shape of an object. Think about a fighter jet, right? There's a very tight tolerance of the coating you need to maintain on that fighter jet. And one of the product line we have is adaptive sanding that does this adaptive sanding operation for fighter jets, drones, missiles, and whatnot, where we have to remove different amount of material from different spots on the very complex geometry very accurately. The tolerance sometimes has to be sub 40 microns, right? So the precision, speed, and payload, all of that has to be tuned very, very accurately to deliver that performance.
Yeah.
And when you think about it in the material removal scenario, right, it's for sanding, you have let's say an aluminum substrate or a composite substrate. Your goal is to produce a certain surface outcome on that. So you have to apply what we call different recipes for the aluminum versus the carbon fiber or fiberglass. You have to apply different force, RPM, contact angle, overlaps. Your sequence of abrasive media needs to be different. So we have to learn these different recipes. There are a couple dozen parameters in the recipe that play a role to produce that right outcome. So all of this adaptive capability has to be there for a robot to enable superhuman performance and deliver the desired outcome for these manufacturers. That's a very complex operation. So when it comes to physical AI and robotics, right, most organizations are focused on robot motion. But robot motion for us was a solved problem many years ago. For us, we have to combine robot motion with all this complex dynamics and minute physics of environment and material to be able to produce that outcome that matters to these manufacturers. That makes this problem extremely hard. And to the date, the reason we are able to do it is actually the real data set that we have collected.
Yeah, I was going to ask you next, is how do you think about data, which is a real gold mine in physical AI? So I think it's a perfect segue.
Wonderful. Yeah, look, the biggest problem in robotics right now is the bridging the deployment gap, right?
Exactly.
You can do only so much in simulation. The kind of complex physics that we deal with, simulation doesn't exist. Simulation is not mature for that. So we can't rely on sim data. So the way we, even from the get-go for the company, we decided that, hey, initially we're going to just deploy robots. We started by deploying point solutions to real customers in the field because we really needed to collect the real data across industries, across environments, across materials, geometries, and applications. Your temperature and humidity affect so much on different material, the lighting conditions, so on and so forth. So we started to deploy real robots and started to collect data. To the date, we have processed more than 30 million square feet of surface area. That's more than 520 football field worth of surface area. And that's growing exponentially, right? We have robots deployed across aerospace, specialty vehicles, marine, national security related operations, and consumer products, many different industries. We have robots deployed across 16 states in the US, across 3 different countries globally. So we have built what we call now a foundation model for materials and processes. We have also built a world model for all this manufacturing environment, in addition to the large skill set that we have developed with physical AI for our robots. And what we have been able to do is we started with sanding when we first started, sanding as an application, and we architected the model such a way that from sanding one material, let's say sanding composites, we were able to branch out to sanding aluminum, branch out to sanding acrylic. Then we were able to actually branch out, taking that lesson and transfer learn a little bit, and branch out to do polishing and buffing and grinding. Then when we mastered, removing material, we actually took a bigger fork on the road, right? And built a new model where we transfer learned the material removal aspect of it, but then taught the model how to do non-contact operations. Then we started to do blasting, right?
Yeah.
Sandblasting, grid blasting, etc. From there, we again forked out to take the non-contact operation model, right? Transfer learn that piece and started to do what we call painting or spraying.
Yeah.
Where now you have to, we have to train the model to understand how to do material adhesion as opposed to like material removal. So our design of architecture from the get-go was, intentional, that we want to do across the board end to end. And now we are able to do it with all the data that we have collected. And, we are deploying a lot more robots to expand that, data flywheel and accelerate at much faster pace.
I mean, it's what I would call a true multimodal, real world, physical AI problem. And now you're really getting to some serious scale, both in terms of number of deployments, but also applications served. How do you think about scaling kind of the data science part of the business? Because as you grow, like you called it an exponential problem, how do you kind of effectively manage and systematically manage your data science program?
Perfect. Great. That's a great question. So 2 parts to it, right? One is collecting the data, right? Collecting the data from the real world. And the second part is what do you actually do with the data, right? So collecting the data from the real world, there is no alternative to deploying real robots. So what we're doing is actually, people talk about sim to real, right?
Yeah.
What we're doing is real to sim to real, right? So we first need to have that data flywheel and the data in, which we have built and that's deployed and that's coming in. From there, right now, actually what we're doing is building some of the sim that doesn't exist or that did not exist in the world, right? And what we're enabling our robots to do or become is becoming robot scientists. So just to give you an example, historically, it used to take us a material scientist, in our company, a material scientist or a process engineer. They used to take 3 weeks to 6 weeks to develop a new recipe for a completely new exotic material. Let's say the Air Force came up with something exotic, right? That engineer or the process engineer or the material scientist, they're running a whole bunch of experiments with the robot to figure out what's the right optimal recipe to produce that desired outcome. Now we have built a technology where it's an ensemble of a few different AI technologies coming together. But what it allows a robot to become a robot scientist. Instead of spending 3 to 6 weeks, the robot is able to conduct its own experiments, figure out a recipe in 3 nights, basically.
And it's exploring kind of the design space and optimizing.
Exactly. And the key difference is that, in traditional AI, you need millions of data points, right? In traditional digital AI. In manufacturing, if you try to capture millions of data points for a given materials, and if you want to explore the full parameter space, by default, you're going to need a lot of parts.
Yeah.
You have to damage a lot of parts. That gets super costly. So that's where our technology is different. The key innovation we had made was that how do we enable the robot, instead of running experiments across the full space, very quickly figure out which subspace where the optima may lie, and become focused there and converge within 20, 30, or 50 iterations as opposed to millions of iterations.
That seems like the hard problem to solve is constraining the problem to begin with. I need to ask you a hot button question. So we've talked about physical AI, we've talked about multimodal data, we've talked about dexterity. A lot of people, when they think about physical AI today, they think about humanoids. We'd love to get your quick take on what you think about humanoids in terms of, hype versus reality, and maybe 5-10 years from now, what the future will look like.
That's a great question. I believe in a future. Have you watched the cartoon WALL-E from Disney?
Yes.
You have? Great. The future will be full with robots of many different form factors and modality and purposes, right? In reality, the future will be like WALL-E or Star Wars or the Jetsons, where you have a range of purpose-built robots to deliver, real performance. At the same time, you're going to have some general purpose robots to do some general purpose operations. Humanoids are great for certain subset of applications, but if we look at our operations in manufacturing, right? In manufacturing, there are two big challenges, or three big challenges actually, for us that we face in our business. One is the technology gap, right? Being able to have the technology that actually solves these really hard, complex, sophisticated problems in the physical world. Second is the change management. To bring robots to the real world, there's a mega change management for existing brownfield factories, right? And that's a very complex problem, and happy to discuss later. And the third piece is, the business case has to make sense for these manufacturers. It's all about the margin, right, that they make. So for the business case to work in manufacturing, all these manufacturers, they need superhuman performance. If we learn from a human performance, right, we are inheriting all human limitations. In the human form factor, in the as-is human form factor, right, the laws of electromagnetics are going to limit a humanoid to be able to deliver high precision at high speed with high payload, all three at the same time. When it comes to super sophisticated sanding, grinding, painting, coating, blasting, like these complex tool manipulation problems, you have to deliver superhuman performance. Humanoids are not the right form factor.
One of the things that I've observed for a long time in industrial categories is that problems are usually chained together. And this kind of goes back to your point solutions versus platform. So complex steps, whether it's things like discrete manufacturing or complex assembly or logistics or construction, they're usually a chain of steps and not a single one. A lot of automation providers come in and maybe they solve one part of the chain. And the problem with that is that you've just shifted the inefficiency from one step to somewhere else. So the rate limiting step just moves. And perhaps your overall system performance hasn't gone up, even though you're solving one thing very well. I feel like the applications you talked about is very much true of as well. If you think about high mix manufacturing, all the different things you need to solve. I think that lends itself very well to being a platform company. Being a platform company is difficult because you have to have generalized AI. And to that point, you're starting to build that. But that's also a big challenge. But I think this dovetails nicely with what we've talked about in terms of factory of the future. And I know that some of your customers, and with some of them, you've deployed initial solutions, you're getting the data, but now the customers want more because they've kind of recognized the challenges that I just outlined.
That's a really great point. From the inception, at GrayMatter Robotics, we have been hyper obsessed with customers and solving real problems for them, right? From the get-go, one of the culture that we set is that let's never fall in love with technology. A lot of robotics companies focus on just the technology as opposed to solving real customer problems. Now, that customer obsession led to what we are observing now is sort of a 3-act play of our company. When we first started, our act 1 was delivering all these point solutions, right? Deliver point solutions, get the real world data flywheel going, start capturing data, have physical AI, start delivering some value to customers. And when we were a relatively young company, when we first started, new technology, new company, large organizations like Boeing's or Caterpillars of the world are not going to make a bet on that. Naturally, we started our journey with small customers, small manufacturers. When we matured the technology and the solution space, we started to receive a lot of pull from all these Fortune 100 to Fortune 1000 organizations, and even US government. And that's when we entered our Act 2, moving towards this upmarket. Then we start to deliver all these solutions to Fortune 100, Fortune 500, Fortune 1000 organizations, aerospace, defense, specialty vehicles, marine, you name it. And what we observed is the following, to your point. When we were giving them a solution, point solution for sanding, and someone is trying to go from building 25 trucks a week to 45 trucks a week, that sanding, even though that was the choke point, it removed the bottleneck from there, that sanding robot. But the bottleneck now moved to painting or upstream grinding or something else, inspection. And our customers were like, okay, we went from 25 trucks a week to now 23, but we need to go to 40. And your technology is amazing. Why can't you do painting? It looks like it should be easy to do that. And we're like, do you understand how hard painting is? But that's when we actually started to expand, right? And with all the bigger data flywheel. So in our Act 2, we start to expand into multiple applications. start to build the foundation models for materials and the processes, the world model for the environments, larger skills model. And then as we deployed more and more applications for some of these customers,
Yeah.
they started asking us, hey, we actually need full end-to-end, because otherwise we can never go from that 20 to 40 per week
Yeah.
production volume. And that's when we start to enter this act 3 that we are just starting now, is doing the full end-to-end factory solutions, right? Bringing autonomy towards the end-to-end, and instead of providing solution as a service, providing factory as a service solutions to our customers. So what that required us to do is a whole bunch of things. Autonomy for robot is just one piece of the puzzle. There's 7 other pieces. We need to bring autonomy in solution engineering. We need to bring autonomy to recipe development that we briefly touched on. We need to bring autonomy in cell design, tool design, factory design.
Right.
We need to bring autonomy in commissioning. Who's going to calibrate all these sensors and the tools and run the test parts to make sure everything's actually working in the factory floor? We need to bring autonomy. We need to bring advanced prognostics and health management, because end of the day, these are all machines. Something or the other can go wrong and will always go wrong. We can't have babysitters for these robots in the factories.
Yes.
We need either AI recovering the systems or have a remote support technician being able to support hundreds of robots in parallel, right? And then there's also the way we're moving forward is that we're receiving a lot of interest from customers to be able to create adaptive, adjustable, rapidly reconfigurable factories. At the time of World War II, Ford was able to reconfigure their factory to build bombers. A clock company was able to reconfigure their factory to build avionics. We need that kind of capability. Today, in a car plant for a specific car model, the only thing you can build is that specific car.
Right.
So the way we're moving in this factory of the future, in addition to all this autonomous capability of doing the operations and doing end-to-end, anything from all the value-added operations in the full chain, also being able to have rapid reconfigurability. It's becoming, to your point, the generalized intelligence. So we're looking at it as a factory, artificial superintelligence for factories. And that factory becomes an organism where you feed your design, you feed your raw materials, the systems auto reconfigures itself. All these robots are on mobile systems or the cells are mobile, and it reconfigures for that specific operation, executes the operation. Now you have mass customization capability, rapid deployment capability. In the time of conflict, you can build up new factories very, very quickly. At the time of peace, you are just repurposing them to do other operations, general, solving societal problems, so on and so forth. So that's the direction where we're moving. And that requires us, the way we see it, it needs to be an ecosystem.
So Ariyan, you mentioned defense a few times. You're in the middle of a really interesting movement around national security, resilience, defense. And this has really picked up in the last just 2 years. And as a result, you're responding obviously to that interest.
Right.
And you've now developed a new motion around that segment to complement what you've been doing on the commercial side. Now, there are a lot of founders who are also seeing an upswell in dual use, and would love to hear about how you navigated that transition, because the two sides are quite different.
Right.
The relationships, the customers, the requirements.
Right. Yeah. So national security is one of our focus in our mission at GMR, and about 18 months ago, we started to receive inbound interest from different agencies, from the Department of War, from the Navy, from the Air Force. There are 2 major problems. Number one, we're not building our arsenal fast enough, and number 2, there are a lot of MRO operations, sustainment operation that needs to happen. When an F-16 comes back, it's sitting down for 5 years, whereas it should be out flying again in 5 months, right? There are 5 million man hours short just in the submarine industrial base. And if you look at the world between World War II until now, tonnage wise, the amount of ship US has built, China has built more than that just in the last 12 months. This pace of innovation is rapid elsewhere in the world. So we responded. We responded very eagerly, and right now our business is dual use, and the business in the government segment, on the national security segment, that's growing very rapidly for us. To your point, the technical complexity is much higher. A fighter jet or a missile or a drone has to be stealth, right? And the material science is a lot more complex. At the same time, when you're working on a submarine or a large aircraft carrier, you need solutions that can work outdoors and in more complex shipyards where it's not designed for bringing robotics to begin with. So we had to really respond, figure out how do we build a team that can interface with the government very, very effectively. So we did that very quickly. We had to also figure out how to breach some of those technology gaps, right? So one of the things that's great about our tech stack is that we're agnostic to hardware.
Mm-hmm.
Our focus is delivering superhuman performance, and our focus is delivering purpose-built performance using general purpose hardware. So we were able to reconfigure for that sophisticated, specification. We were able to introduce new sensing modalities, right? And our models are adaptive. So it was very easy for us to solve the problem and very quickly move there.
And do you have two dedicated sales teams?
Yeah,
effectively
the motion
one
is very
working
different.
and they're basically siloed, but getting very good individually at what they do.
Correct. Yeah, it's two different motion altogether.
Very different competencies.
Very different competencies.
I want to talk a little bit about, speaking of customers across both sides, I want to talk a little bit about getting customers to buy.
Yeah.
So you recently moved into a super impressive 100,000 square foot facility, which does many, many things. Mm-hmm. A lot of R&D, a lot of recipe development, and one of the things that I think it does best is it showcases the range of applications that you support, from football helmets to fire trucks. So a lot of different applications, a lot of different form factors. One thing we've seen with the company is that whenever you get a prospective customer on site to your facility,
right,
the sales conversion rate goes way up.
Yep.
What do you think it is about robotics and this kind of seeing is believing moment? Right. And maybe related to that, have you observed certain things about the product in action? What is it that blows people away when they really see it and kind of, convinces people, wow, this is possible. I never knew it could be done this way.
That's a great point. So we have, we built out this 100,000 square feet physical AI experience center for our customers in Los Angeles. So by the way, if anyone that please send them our way. Would love to give them a tour, right? And showcase what we're doing.
Be careful what you ask for, Ariyan. You may get a flood of people going through the doors.
Well, we can keep a qualification.
Okay.
So that has been tremendously helpful, because think about it this way. If you're a Boeing or a Caterpillar or Oshkosh of the world, or US Navy or US Air Force, you're not going to bring a sophisticated technology that requires complex change management. You have to readjust your facility and the workflow. So for large enterprise organizations, it's impossible for them to acquire a new technology without validating or certifying. Mm-hmm. That's where our experience center plays a big, big role. So at any given point in time, if we host someone, we're able to showcase and demonstrate how our autonomy, our physical AI, is able to work on anything from football helmet to a fire truck to a fighter jet to a submarine. And on top of that, when someone is taking a first call with us, let's say if you're an end user, you are on a Zoom call with us, and we show you a technology that's as simple as using a microwave. In a microwave, you put your food, you press a couple buttons, popcorn or bake my chicken or something. Your food is ready in a few minutes. And we showed them that, hey, it's exactly like that. You bring your part in our robot cell, you press a couple buttons on the screen, your part is ready. To vast majority of the people, that looks like
magic.
Looks like magic. Yeah, people don't believe that. But then when they come see it in action, their mind blows away. And they start seeing all the possibilities, and then they start pushing us. Hey, why not this? Why not that? Why don't you do this? Add this to your roadmap. So it's an incredible, way to bridge that gap and build conviction, and demonstrate that that technology exists today and it can deliver this value, and also demonstrate what are the limitations of that technology and what's coming on our roadmap.
I have two quick questions to follow up on this. Is there any way to bring a piece of that experience to the road? And how do you think about field sales?
Right. It's difficult. We thought about it. Some of our, our sales team has been pushing me that, hey, why don't we even put a robot cell in a semi, and you just take it from different state to state or city to city, and we do roadshow and this and that. The challenge is basically, as I mentioned, we deliver purpose-built performance with general purpose hardware. If we want to demonstrate the true potential and the power, this robot is now an industrial robot arm, the most general purpose hardware form factor, but that's big and heavy and bulky. It's not easy to move around. So that's difficult. And but what we're seeing is that with the technologies and everything, right, we're able to create a virtual experience as well that's more immersive, and that's helping quite a bit. The other piece is with more robots deployed across all over the map, all over geography, we're able to take customers to some existing customer and give them the same experience or similar experience.
Well, I just want to call out, by the way, as we talk about sales, it's hard not to talk about marketing. You have some fantastic marketing videos. It's one of the things that attracted me to the company. It's a little bit of the seeing is believing part, and you brought it through videos and customer testimonials. How did you first get the sense that this was going to be really important for you? And should the viewers expect more great videos to come still?
Yes, there will be more great videos coming up. There will be some really exciting videos coming up later this year on some of the newer platform, like, for example, actually, I'm not going to reveal that right now.
Yeah, keep us in suspense.
Very exciting thing for super complex objects. And by the way, the videos you see from our customer testimonial, none of them are scripted. These are all raw, unscripted voice of the customer.
I think the authenticity comes through, which is really what makes it powerful. And it goes back to the quality of life part, the quality of experience in life.
Exactly.
And I think there's always a fear of automation and this will displace us. But clearly the customers aren't saying that.
Exactly. So what we realized, to answer your first question, we realized that our customers are the best. They're the best in describing the benefit and the power of this technology and how it's really transforming their business. They were narrating the same thing to our team members. And we were like, hey, would you be open to saying these things on camera? And then we just put a camera in front of them. It was raw, unscripted voice coming up, talking about how the technology is transforming their business, bringing all this business outcome, how it's helping and improving quality of people's lives, to your point. One of our customer, Rydell, they're the largest football helmet maker in the world. One of the profound story we have is that they were able to bring back one of their retired employee who was injured but who was very well respected and very loved in that company. They were able to bring him back. Now he's a robot operator. Many of our end users, they give a call to our engineers a few weeks after deployment and they tell them, hey, thanks for making this magic robot. I can now go back home, play with my kids or my grandkids. My body doesn't hurt anymore. I believe the reason we have all these great stories is because this solution truly transforms all these businesses and the lives. Let it be a football helmet manufacturing or let it be fighter jet manufacturing.
It's amazing. I mean, there's nothing like having that human impact, and I think that pulls on the emotional piece and it influences decisions. It's great, and it serves directly kind of the mission of the company.
By the way, Debjit, quick question for you.
Yes.
You asked me about the facility. What was your first impression when you walked in?
I thought the size of the facility blew me away. I just didn't realize how big it was. I'd seen pictures of it. But I think the other piece was, given the size, it's what you're able to do with it. So when I saw, and I'll give you an example, the mock-up of the 737 wing, and you basically are doing finishing on the bottom of that wing, which is such a difficult problem for a human, given the elevation and given the change in geometry and given the sheer size of it. It's such a massive job. I think those experiences really come through, and it's very visceral. And so I think it's that experience center is aptly named. I think it truly is an experience. And I think hits more closer to home for me just in terms of what robotics can do in terms of changing lives and industries than most that I've seen. So I think you've done a fantastic job.
Do you have any recommendation for other founders who are coming to the space in terms of how they should think about customer acquisition or bringing this experience to customers?
I think you've kind of shown them the way in a bit. I really like your approach. I think that, first of all, if I think about robotics, the best way to show value is to simply go to the customer and prove ROI. I think at the end of the day, the customers are less obsessed with technology and the way that you get there. They just want to see results. And so to me, I'm a very ROI focused kind of investor.
Exactly.
You show the ROI, and you show the reliability and robustness of performance, then you've got them. That's my feeling. I think looking at robotics over so many years, what I've found is that in industrial applications in the field, whatever can go wrong does go wrong.
Exactly.
And so
Exactly.
having an incredibly robust, reliable
Yeah.
solution that won't fail you when you need it most
Right.
is the way to go. So there's a
Right.
lot of proof in the product, but as it
Right.
relates to promoting it and getting
Yeah.
customers a piece of it, I think what you've done in terms of both the videos and giving kind of the human story behind the visuals, but then also having a place where you can see it in action
Right.
is incredibly helpful. There are some robotics and automation solutions where you can potentially do what you alluded to, which is have a bit of a roadshow. And I think that's a great idea as well.
You added a really good point about the reliability and the robustness. And that's where, not just the giving the customer experience, but also what really worked in our favor is being transparent with them that, hey, these are machines, something can go wrong and will always go wrong. However, we are here committed to deliver you 95 to 99% system uptime, and then 97% of the issues will recover under 5 minutes with all these technologies. And those numbers are going up. I think the first time we spoke 4 years ago, I think our numbers were like in the 70% range, but now, in that close to 99%. So it's crazy.
So Ariyan, we talked a little bit about ROI and positive business outcomes. What are the metrics that you follow to make sure that you're hitting those?
Great question. So in manufacturing, what we have found out after working with so many customers, dozens of customers, what we have found out is that what truly matters to them are two things. One, productivity or throughput, right? How many parts that you're able to get out the door in a certain unit amount of time, right? And footprint or the real estate is scarce and rare. So it's always how much more you can get out of the same footprint. That's important. So throughput is the most important thing. And then the other equally important thing is cost per unit.
Mm-hmm.
No one will introduce these robots if the cost per unit goes high, if they need to take more parts out the door, right? So the cost per unit has to go down. So whenever we work with customers, we focus on those two metrics. How do we improve their throughput, increasing their capacity, and at the same time, reducing the cost per unit?
Do you have a kind of a rough percentage in mind in terms of the range that you're trying to hit?
It's a big range depending on customers.
Yeah.
For example, let's say when it comes to a fighter jet or a shipbuilding, it's very different compared to, let's say, something consumer product or even a truck.
That makes sense.
I'll give you one example. For example, we work with the largest tow truck manufacturer in the world. They're an international organization. They have a $2 billion backlog of tow truck. I don't know who's buying all the tow trucks, but it's crazy.
A lot of cars are breaking down.
They, with our technology, they were able to triple the throughput while reducing cost per unit by 40%. So that was a really big gain for them. So they were able to compress the backlog to now, months as opposed to years. And still their cost efficiency went up. So it's an impact on their top line as well as the bottom line.
Amazing improvement. To wrap up, I'd love to hear from you on your founder journey a little bit. It's always unpredictable. You've learned so many things along the way. I'm sure ignorance was bliss in some ways.
Ignorance was bliss.
But if there's one thing that really surprised you, and I'm sure there are a number of things, but maybe pick the thing that stands out the most in terms of what surprised you about this journey, what you never would have guessed. And if you had to go back to your PhD commencement and tell the newly minted Dr. Ariyan Kabir what the future held, what would you say?
I can think of a couple things. 3. It's less of if we want to build a real business, right? At the intersection of robotics and AI and deliver real value, technology is just one piece of it. It's truly the people that we have to pay attention to. The CEO or a president of a company cares about something different compared to the middle layer who will bring this solution and bring the change management to actually adopt the system. They care about something very different compared to the operator at the end of the line who's using these robots and the automation day to day. They care about something very different. So understanding the people aspect of things is super critical. And I never even realized that during my PhD, to be honest. Another thing I can think of is that, at that time I was of the impression that, hey, if we bring the best people doing AI, best people doing robotics, we can solve the problem. What we learned the hard way, it's not really true. We need people because the problem is so complex and the details are so important. We really need people at the intersection of robotics, manufacturing, and AI, all three,
That makes sense.
to make rapid progress. And that's very, very rare. I mean, we are very fortunate to have few people in our company who comes from that unique background. But what we now end up doing, at least hire people from intersection of two out of the three and groom them very quickly on the third. But that domain, familiarity is super critical to be able to make progress. Otherwise, you're trying to apply certain tools and techniques that doesn't really work in this domain.
One final question. If you weren't a founder, what would you be doing?
If I were not a founder, what I would be doing? I don't know, to be honest. I mean, even in my, I always wanted to, I need a sense of purpose, to be honest. I
Yeah.
really always wanted to do something very impactful. Even when I was like writing the, SOP for my PhD application, there was a paragraph about how we really need lot many more companies doing robotics and AI to make a real transformation in the world. And today we are seeing that. So this is 2014 when I was applying to grad school. But in 2026, we're actually seeing that lot many more companies are coming up. So which is amazing. Love that. And we need that to build this future that we're building. If I were not doing what I'm doing today, probably I would, and if I'm not doing something super impactful for the world, probably I'll be on a mountain in Patagonia or something. Yeah.
Well, it's been a great conversation, Ariyan. It's always a special moment and a pleasure to talk to you and to trade notes on robotics. I think as I look back on our journey, it felt like we bonded and kind of geeked out over technology, and I was really impressed by what you were building and your sharp spike of tech expertise, but also the size of the market. I think, since investing and being on the board, we've also now talked a lot about scaling, and now we're solving a lot of sales metrics and scaling problems together. And I think the challenges continue to grow, and that's really exciting. There's always something to look forward to, and there's always more mountaintops to tackle.
Exactly.
But it's been a great journey, and I look forward to a lot more in the future.
No, thanks for having me, Debjit. It was wonderful. And yes, you're right. It's, the highs are high, the lows are low, but it's not like this. It's been like this.
Exactly.
So, which is very exciting.
Exactly. Fantastic. Thank you so much.
Thank you.
All right. Thanks so much, Ariyan.
Thank you, Debjit.
Great to have you here again.
Thanks for having me.